Sure. So I'm going to talk to you a little bit about forestry applications and the role of Landsat. And one of the things that is implicit from some of the remarks that you've seen before is that Landsat users have moved to supplementing land use and land cover studies to essentially looking carefully at within land use management. And I want to make this point very clearly, that once you know the land use, you can still use Landsat, and you can use it really, really well. And the forestry community is something, provides these unique contexts that I'll just kind of mention a little bit today before I kind of get to the more or less the user requirements part. In terms of applications, things that you may not have been aware of is that operationally many forestry companies will routinely do leaf area index calculations throughout the year. They'll use that to determine the amount of competition within a particular type of stand. They'll take a look at that leaf area accretion rate through time to understand growth and subsequently model yield. They will take a look at that leaf area index, and they will be able to understand when, how, and if to fertilize a stand, when it should be thinned, whether it's been thinned. So we have this unique set of possibilities that has emerged. And there are really a few kind of critical kind of components of Landsat data as they've emerged in this community that I want to kind of point out. And I kind of call them the 3 C's. The first really is the explosion that we've seen since the no-cost data policy. The first of those is cost, okay? It's really absolutely essential for the wealth of applications that's emerged that essentially we not have to kind of go back to that era where we had to pay $600 to $5,000 a scene, okay? The second is continuity, and every speaker today has spoken about this, and Dorothy most explicitly in her last slide. It's how a particular observation fits into the history of observations over that area that is absolutely essential. And I think of it as kind of critical infrastructure. You know, you have a superhighway system in the United States, our interstate highway system. We may decide to add lanes to them. We may decide to add state roads that access them, but in the end, you still have to have the core infrastructure, and that data continuity with our past missions is the core infrastructure. And the last of the 3 kind of C's that I think have enabled these sorts of applications is calibration. And I want to mention this very, very explicitly because it really means that radiometrically that we can assume that an absolute measurement, okay, can be used in a way that allows a decision to be made. As or more important, that any single measurement can be used across time and sensors in a way that allows the comparisons that enable the decision support. If that's not the case, you just blew it. So again, cost or lack thereof, calibration, and continuity. And one other thing I want to kind of mention in the calibration side is that ultimately geometry is really important. Curtis mentioned the fact that we are moving into a pixel-based world. We may move in the next 10 years to a situation where the idea of having a WRS 1 or 2 is somewhat archaic. That we may, in every instance, go straight to the pixel in every single reasonable observation that's been acquired over that place. And you just must be able to spear through time and ensure that you're not seeing the pixel next to you or 2 over or 3 over rather than the one in which you have an interest. A pixel-based analysis absolutely requires the kind of geometric fidelity that enables it, okay? A couple other things I'll just mention as I blast through here in terms of other applications and things that we should be thinking very carefully about. Forestry is quite unique in one way that I think is even a little bit different from agriculture, is that the time scale of decisions are perfectly appropriate for Landsat. That you can, in many cases, you're making interannual decisions with intra-annual observations. In other words, the timing of an observation in a given year is absolutely essential. But it's in fact whether you're going to do something that year and how much of something you're going to do that year that is more of what's happening in terms of that decision support. Are you going to fertilize this year? How much? Are you going to harvest this year? Maybe you shouldn't. So it's really the time scale that's absolutely pertinent. And at the same time, the spatial scale is really the scale of management. And Martha talked about this as well as Rick. This is the scale at which humans are interacting with the landscape in many instances. There are certainly exceptions in, certainly small tracts in Africa or Taiwan or the like, but it's definitely the scale at which humans interact with the landscape. And as I close, because I think we want to allow a lot of time for discussion, I want to just kind of give you an idea of the kinds of, just examples of the kinds of importance that certain companies have attributed to this. We had a recent instance that was a big scare for our community where we had a very well-known U.S. Forestry company that filed a patent on the use of Landsat and associated spatial data for their internal management decisions. That fortunately was denied because of the very extreme amount of literature on this subject. But this just goes to show you that there are folks that realize how important it is. They're actually trying to put fences around it. Similarly, and I can't say who, but I've been interacting with a number of other companies over the last several years that have asked me not to mention them, but their internal processes use Landsat routinely all the time. Not only for the kinds of land management decisions I'm talking about, but even whether to acquire or sell a property. Everything from due diligence to its potential productivity of an acquisition. So all of these kinds of things you may not have thought about, but ultimately they're really a big part of the way that we do business in forest science and management. The last thing I'll mention in terms of an operational program that, again, you might not have heard about, but it's just a few miles down the road. The Commonwealth of Virginia will give you a tax credit if you claim on your tax return that you have forest land that is adjacent to a stream that you have protected. You, in order to obtain that credit, have to send a shapefile to the Virginia Department of Forestry, and what do they do with it? Every year acquire Landsat imagery, compare it to the previous year's imagery, and they double check to see whether you've managed to keep it or not. Okay, this is just a couple of examples, but I can tell you it is has just permeated the industry. The last, just kind of come back to what I've said. It's the availability of no-cost data that's intercalibrated, okay, and that has continuity with the prior data that has enabled all of this to happen.
Thank you very much, Randy. What I'd like to do is move to the audience here in the auditorium. And then to the people of the remote sites, they'll come back and give the panel one final opportunity for concluding comments, and then we'll move to the questions that you've translated from the officers. So, do you have any questions or comments from the auditorium?
Hi.
Sorry.
Please identify yourself and your affiliation.
Hi, can you hear me? Okay. Nadine Trahan with Gaia Spatial LLC. So a couple of questions, two questions for USGS and NASA folks, and then I guess if the panel could comment. One is, they're both in terms of requirements, assessing requirements for, say, Landsat 9 or in general. One is about the integrating unmanned aerial systems as the technology grows and the regulations open up. Is thought given to having UAS and satellite systems complement each other in terms of data products? And the second question is whether this, the hyperspectral. I just saw a short note up there about some hyperspectral questions. Is that a long-term possibility?
Yeah, I'll answer that. First of all, UAS is something that I've now heard several times people bring up that there's something that you could have unique areas where that would solve the problem, where we don't need orbital access to address that data. Is something we would definitely consider and add into this architecture as well. like I said, if we don't need orbital assets and we can satisfy a need that arises, we would definitely consider that as a implementation approach. As far as hyperspectral goes, it didn't appear in the charts, but that was the direction we were also given, was to assess how that would, how the system may evolve into using hyperspectral instrumentation to provide the data necessary. But we've got a study going on to specifically assess the usability of hyperspectral data for Landsat uses. So that is also part of the mix.
I would just add that you saw John's presentation earlier, and the point of the requirements activity is to gather all land imaging requirements. So some may be met by a Landsat-like system in space, some may be met by UASs, some may be met by other types of aircraft, ground sensors, if you will. So it is our intent in this bigger study, in the bigger requirements activity, to understand all land imaging activities. In fact, today we do have UASs, and we do try to sync them up with collections that are from overhead from space assets. So it is something that we think about a lot. And I would just say for hyperspectral, one of our aspects also, one of our goals is to collect information on many potential solutions for these requirements. And hyperspectral certainly would be a potential solution for some of these.
I'll agree with what Tim just said. That's exactly what I was going to answer pretty much the same thing that Tim just said. The way we would address that in our requirements evaluation system is that these are solution types. Okay, so your requirements are managed separately from those. You have your UAS as a platform, as a solution component. The sensors that go on them are solution components. Hyperspectral is a sensor type, and they can all be compared against requirements if they're included in the architecture as solutions.
Do we have any other questions?
Yeah, hi, Steve Unger. I just am wondering, I feel bursting to make comments, but I want to address questions really to the group. And how important is band-to-band registration for all of your applications? I know the forestry is, because I feel obliged to do this as the former EON mission scientist, and right there is the former EON project scientist, Dr. Kramer. One of the things that we learned in ALI, lessons not learned, was that it's difficult to maintain inherent band-to-band registration, although every other aspect of the push-pull system is great. And the reason the signal-to-noise is so high is that we're not looking at the same area of the ground simultaneously. So my thoughts were, at least from some of my colleagues who are in the hyperspectral world, was a concern about if you don't have inherent band-to-band registration, it becomes an issue when your analysis techniques depend on ratios and combinations of ratios. So the question is this an issue that will need to be addressed in the future Landsat as you refine and try and get more and more accurate measurements? And if so, is this something that you guys can take into account when you do your evaluation of how the next system should be? I mean, there are more than one solution. One is that there are many ways to get the bands required simultaneously, but that's a discontinuity in what's happened with from previous Landsats, because although signal-to-noise along with the scanners, the 16 have been fairly well aligned and along the focal planes and in notice at least with the visible bands, so that you're getting the same radiation from exactly the same spot on the ground. You're talking about becoming pixel-oriented. If you're going to actually average ratios, it's not the same as the ratio of the averages is not the same as the average of the ratios.
Well, I think you yourself said it's critical. I'm eager to answer the question as you asked it. Like many of these things, the bottom line is how much is enough. And I think that's where the kinds of studies that are essentially being undertaken at this particular juncture hopefully will answer that question. But it is a major issue associated with push-bring scanner in particular. And it is one of the things that's led, of course, to our terrain-based registration as it currently exists. And there are improvements that are occurring as we speak, even in Landsat 8's
registration process. Curtis, I think you had some things you wanted to add.
Just that with Landsat 8, it's been great.
Say that into a microphone.
That's the experience today in terms of, van registration for Landsat 8 has been great. They've done a really good job.
If I could just add something. We need more than one mic.
Yeah.
Can I add something? Well, okay, that's it then. For the energy balance algorithms, it's also critical for most algorithms to have good registration between the thermal and the shortwave bands. We need to accurately define albedo to get the net radiation correct, and the amount of revegetation cover really affects how we interpret the surface temperature. This is also one concern I have about separation, significant separation between thermal and shortwave sensors on different platforms. We're going to degrade that band resolution. We're going to introduce errors in the water balance retrievals.
I don't want to jump back to what you guys want to hear. But the other thing I was going to say, is this working?
Yeah, and it's
Okay. The other thing I was going to say is time also matters. So we need to be careful as we start to think about new sensor designs that essentially will be separating the acquisition of certain bands in time because of multiple platforms. We need to think about carefully as we've got these things nicely geometrically co-registered, but they're some distance apart in time. How much of that is reasonable for given applications? And again, I think that's part of the set of studies and kind of user-based requirements that we're hoping to conduct. But that question was also implicit in what you had indicated.
Is there anybody off-site, remotely, that has any questions? Please remind me to take your phone off mute if you do.
Hi, this is Deborah Warner from Space News. I wondered about the current health of Landsat 7. How much longer do you think it has?
This is Tim Newman from USGS. On Landsat 7, the fuel will last another 3 years, maybe 3 to 4 years potentially. As far as the spacecraft itself, there are some issues. There are some gyro problems, and there are some other things that we've been watching, which of course on any operational spacecraft could fail almost at any time. But we do reasonably believe, if you can believe me, that it'll go for another 3 years or so. I think that's what we're looking for from Landsat 7. Does that answer your question?
Yes, it does. It just sounds like that's not much time to build and launch a new spacecraft.
I would agree. I would agree.
We're having microphone issues here, but yes, we would agree. Any other questions online?
Okay, I'll presume we don't have any more offline. I'd like to go back to the panel to see if they have any final comments they'd like to make on this section before we move on to the other questions.
I guess what I'd like to do is, as sort of a summary comment, is try to put a little bit of perspective on the charge that the Sustainable Land Imaging Group has been given, because it's and one is to say that I'm thrilled that it's happening, that we're finally getting around to the idea of sustainable land imaging, and I'm thrilled with the urgency with which we're getting around to working on sustainable land imaging for exactly the reasons that have come up in the discussion so far. We have a limited life for Landsat 8. We have most of the history of the Landsat program, we've had 2 Landsat satellites up, and so we've had effectively 8-day repeat times. And so to sort of maintain the continuity with the history of the program, I'm very pleased to see this moving forward with urgency. But one of the points that I'd like to make is that the Landsat archive is one of the definitive data sets for understanding the way our world is changing. Okay? Right from the beginning, there were some fabulous decisions made about collecting and archiving global data, and that has proven to be incredibly valuable in many contexts, all the way from global scale studies of things like climate change, and Dorothy gave you some nice examples of that, all the way down to the land management scale. Landsat has hit a really nice sort of middle ground that's global, but at fine enough resolution to enable local management issues. And that's a really sort of critical sort of characteristic of the data set. And so what is all that success based on? Well, we got Randy's 3 C's, which I think are exactly right. The other one I would like to point out, though, that adds to this whole process, and Landsat 8 is a great example of this, has been the incremental improvement process, right? We haven't stayed, there's been continuity, but there's been a steady improvement in the characteristics of the data and the observations as we go forward. And if there's one place, I think as summary from everybody who's mentioned this, that there would be the most incremental improvement or the most desired incremental improvement, it would be in the frequency of observations. And so if we can take that as sort of a lesson looking forward, that's where I think we would most like to see the biggest improvements, if in fact we get the opportunity to do that.
Anyone else on the panel?
It's Rick Mueller again. One thing I would like to address is, I totally agree with Curtis. It's great to have a Cadillac-type instrument like Landsat up there and observing. It's a great observatory, but 16 days, if this is what we're going to get, again with Landsat 9, it's just not enough for the government to do the ag monitoring that we need to do. If there was the ability to have a lesser calibrated system of small sats, that would be a lovely idea, a wonderful concept. We would totally embrace that and adopt that. We don't need super duper precise calibration to do our land cover classifications. We did it last year with the DMC data, and given what it is, our results were attainable, and they worked out all right. So if we had the ability to have one Cadillac and a couple of Pintos surrounding it, that's okay. I would totally support that. We would appreciate that. Oh, sorry for the younger generation. Smart cars, zip cars, something.